Chapter 11 is called the mole. So what is a mole? It is the SI unit of amount. When we are measuring matter in chemistry, we can measure it one of three ways. We can measure it with mass, we can measure it by counting particles, or we can measure it with volume. So we're going to start with measuring by mass. It is the SI unit of amount. When we are measuring matter, we can do it in one of three ways. So you can measure it with mass, you can measure it by counting the particles, or you can measure it by volume. So we're going to start with measuring matter by mass. So this is called molar mass. Molar mass is the mass of 1 mole of a substance. The unit is in grams per mole. The mass of atoms is found right on the periodic table. It's the number that's under the name of the element. It's a decimal number. I'm going to want you guys to go to at least 2 decimals. If you want to just use the whole number, that's fine as well. So if we're looking at potassium on the periodic table, which is atomic number 19, it has a mass of 39.10 grams per mole. So what this means is that 1 mole of potassium will have a mass of 39.10 grams. If we have a compound like water, let's ignore this carbon dioxide. If we have a compound like water, we have to calculate its mass by adding up all of the atoms in it. So hydrogen has a mass of 1.01. There are 2 hydrogens in your formula. Oxygen is like 15.999. We're just going to call oxygen 16. There is 1 oxygen in your formula. So that would be 2.02. And you're going to add these together, so plus 16. And the mass of water then would be 18.02 grams. So that means 1 mole of water has a mass of 18.02 grams. When you have bigger compounds, doesn't really change how you add the mass up. You just got to make sure you're adding the mass of each individual thing. So barium acetate, remember when you're putting a formula together, you use the charges. Barium's a +2. Acetate's a polyatomic ion, and it has a charge of -1. So barium acetate is going to be BaC2H3O2. So when I'm getting the mass of that, it's not really any different from getting the mass of water. I'm just going to look for the masses of each of my individual elements. So barium has a mass of 137.33, and there's 1 barium in this formula. Carbon is 12.01, and there are 4 carbons in the formula because this 2 here distributes and multiplies. So hydrogen is 1.01. There are 6 hydrogens, and then oxygen again is 16. Call it 16.00, and there are 4 oxygens. So let me get my calculator going here. This is obviously going to be 137.33. This is going to be 48.04, 6.06, and then 16 times 4 is 64. So add those up. Let's see. 3, 4, 10, 15, 10, 13. I believe it to be 255.43. Let me just double check. Yeah, 255.43 grams is going to be the mass of 1 mole of barium acetate. Okay, so that's how you add up molar mass. Now let's look at how we use these in our conversion. These conversions are just like when we did, how many feet are in this many miles or whatever back in chapter 2. It's just that your conversion factor is going to be different. Your conversion factor that we're going to be using here is 1 mole is the number of grams off the periodic table. So I always say to underline what you are starting with and to circle what it's asking for. It's just going to help you keep track, especially when we get into longer problems. And then the process of doing these is always the same. You're going to write down what you're given, 12.5 grams carbon dioxide, and you're going to make this T. And then whatever unit you wrote down at the beginning is always going to go right there on the bottom so that it cancels. That's always how you start every single problem. On top, if we look at our conversion factor, the number of grams equals 1 mole. So my unit on top is going to be a mole. 1 is always going to go with mole. And then to get grams, you add it up on the off the periodic table, just like we had been doing on the other couple slides. So carbon's 12.01, oxygen is 16. There's 2 oxygens, so it's 44.01 grams will be the molar mass of carbon dioxide. To solve this, what you're going to do is you're going to multiply everything on the top. Oh, we should have put that somewhere else. So we're going to do 12.5, divide by what's on the bottom, and let's see what we get here. You get a pretty long decimal. You get 0.284026. That's probably enough to write down. Now, every answer is going to need 2 things. It's going to need significant digits, and it's going to need units. So significant digits are based off of what you are given in the problem. This has 3 significant digits here. So I'm going to round this number to 3 significant digits. To do that, you just count to your 3rd significant digit. So 1, 2, 3. Now that last digit right there, that's the only one that possibly could be rounded. We look at the number next to it. The 0 is going to make it stay the same. So 0.284, that's my 3 significant digits. And then your unit is going to be whatever is left over right here in that upper right box that's left uncrossed off. So in this case, it is mole. And so there is my answer, 0.284 mole carbon dioxide. So let's do another one. I have 83.2 grams of sulfuric acid. I want to know how many moles there are. So we're going to write down what we're given, 83.2 grams H2SO4. We're going to make our T, and then we're immediately going to put that same unit on the bottom. Every single time, doesn't matter what you're starting with, that's how you start those problems. And then we're going to go to mole on the top. 1 always goes with mole. And then with grams, we're going to add up off the periodic table. So the hydrogen is 1.01. There's 2 of them. Sulfur is 32.06. And then oxygen is 16. There are 4 oxygens. So that's going to be, let's see here, 64 plus 32.06 plus 2.02, 98.08 grams. So that's going to go with grams. And then again, we're just going to multiply across the top. So 83.2 divide by what's on the bottom, 98.08. And round my answer to significant figures. So that was 3 that I started with. So we're going to round it to 0.848. And again, unit is what's left uncrossed off, mole H2SO4. Let's go the other way. So starting with mole and going to grams. Doesn't change how you do the problem at all. So here, let's do this one with oxygen, because we remember that oxygen is diatomic, is O2, right? Which means I'm going to take its mass and I'm going to multiply it by 2. So oxygen's mass is going to be 32 grams per mole. So I'm going to underline what I'm starting with, circle what it's asking for, write down what I'm given, make my T, and cancel that unit every single time. That's what you do. So don't try to think about like where does the 1 go, or you know what goes on top, or just like cancel the units when you put your units in first. These problems become really, really simple. So I put mole on the bottom. It's asking me to go to mass in grams, so grams is going to go on the top. 1 always goes with mole, and then grams is what I added up off the periodic table. In this case, those two numbers are next to each other, so we're going to multiply them. And we're going to round, because this was 3 sig figs, so we're going to round to 3 sig figs, and we're going to get 24.8 grams O2. Okay, so that is counting by mass. Let's look at counting with particles and with volume. So as I said at the beginning of this presentation, the mole is the SI unit of mass. It is a very large number, just like you know how a dozen is 12 of something. A mole is an amount. It's just a lot of it. A mole is 6.02 times 10 to the 23rd representative particles. This is called Avogadro's number. It just was named after this guy, Avogadro. So 1 mole of anything is 6.02 times 10 to the 23rd of that thing. If I had 1 mole of pennies, I would have 6.02 times 10 to the 23rd pennies. We're talking, though, about chemistry here, so our representative particles are going to be atoms, molecules, or formula units. And so the word that you use just depends on what kind of particle you have. If you just have something off the periodic table, like potassium or argon or whatever, then it's called an atom. Remember those diatomics, however, those are not called atoms because it's never just H by itself or N by itself. Those are molecules. Molecules is the term you use when stuff is covalently bonded, which is going to be non-metal bonds. And then formula units is when you have ionic compounds, which would be metal, non-metal. So I would use the term atoms, like I said, if I just had something like, I don't know, potassium, I think I said, or argon, or copper, or whatever, anything that's just an atom by itself. Molecules I would use when I have something that's covalently bonded, non-metal, so like water, carbon dioxide, I would use the term molecules. Formula units, ionic compounds, so sodium chloride, or magnesium oxide, or calcium nitride, sorry. Those would all be formula units, would be the term that you use. So again, process really isn't any different. We're just using a different conversion factor here. We're using 1 mole equals 6.02 times 10 to the 23rd. And again, you're going to use that with the word atoms, molecules, or formula units. So I have 2 moles of argon. I want to know how many atoms there are. Process has not changed at all. This is exactly the same as every single problem we did before. We're going to write down what I'm given, 2.00 mole argon. I'm going to make my conversion T. I'm going to put mole argon on the bottom. Cancel, cancel. It's asking me to go to atoms, so I'm going to put atoms on the top. So 1 still goes with mole. 1,000,000% of the time, 1 goes with mole. What's different here is I don't need to add anything up off the periodic table. I see this word atoms, and so I'm going to use the conversion factor for atoms, 6.02 times 10 to the 23rd. You're going to multiply those two numbers because they're next to each other. And so what you're going to get is 1.204 times 10 to the 23rd, 24th. Yep, 24th, sorry. Trying to mental math here. Can fix that. 10 to the 24th. Sig figs, this was 3, so I'll round this to 3 sig figs. 1.20 times 10 to the 24th. Unit is still what's left up in that upper right corner, so atom of argon, write that a little bit better, is going to be my unit, and you just put that next to the times 10 to the 24, so atom argon. Okay, so there's that one. Going the other way, if I'm starting with 1.62 times 10 to the, 1.62 times 10 to the 23rd atoms of argon, and I want to go to moles, nothing's really changed. We write down what I'm given, 1.62 times 10 to the 23rd atom argon. Make your conversion T, cancel atom argon on the bottom. Every single time you do the same thing. We're going to put mole. It's asking me to go to mole, so I'll put mole on top. 1 always goes with mole, and then 6.02 times 10 to the 23rd goes with atoms. So these ones you would divide. Let me just get my calculator here. There we go. And you are going to get, with this is 3 sig figs, you only look at the number and the coefficient. So this is going to give you, sorry about that, 0.269 atoms of argon. And that would be your answer. Okay. When we're looking at volume, this is our final conversion factor. Our final conversion factor is 1 mole equals 22.4 liters. And that's of any gas. Doesn't matter the identity of the gas. Any gas is going to occupy 22.4 liters at STP. STP is standard temperature and pressure. So it's a temperature, it's a pressure, because if you change either of those, the volume of your gas would change. So standard temperature is 0 degrees Celsius, standard pressure is 1 atmosphere. It doesn't change how you do the problems at all, but most of them will say at STP, just indicating that you can use that 22.4 conversion factor. So, what is the volume of 1.5 mole of nitrogen? Same thing that we've been doing this entire time. We're going to write down what I'm given. We're going to make our conversion T. We're going to cancel that unit. And then this time it's asking me to go to volume. When we see volume, we know it means liters. So liters of nitrogen is going to go on the top. N2, of course, because it's diatomic. 1 is still going to go with mole. And then our new conversion factor, we put 22.4 with liters. Multiply those two numbers together, and you'll get 33.6 liters of nitrogen. Okay? Go the other way. If I'm starting with liters and going to moles, doesn't change the process. We write down what I'm given, make my conversion T. Oh, liters water. Cancel that unit. And then we're going to go to mole on top. 1 always goes with mole. 22.4 is with liters. So we would multiply everything across the top and then divide by what's on the bottom. And I believe you get 3.36 for that. Again, unit is what's left on the top there, uncrossed off, mole of water. Okay, so those are one-step problems. And the good news is, I know that was kind of a lot, but those 3 conversion factors are the only conversion factors that we are using for this chapter and for next chapter. So once you really get this process down of writing down what you're given, canceling the unit, this really becomes quite simple. Let's look real quick at some 2-step problems. So when we are converting between units, you always have to go to moles first. Our 3 conversion factors are 1 mole is the number of grams off the periodic table. 1 mole is 6.02 times 10 to the 23rd. And again, we use that with different words: atoms, molecule, which abbreviate formula units, and then 1 mole equals 22.4 liters. So if we had to convert from, say, grams to liters, I don't know how many grams are in a liter or how many liters are in a gram, but they both go back to moles. And so every single time you're doing one of these conversions, you have to go to mole town first. I can't go directly from like how many atoms are in this many grams of iron, because I don't have a road there, right? There's no road there. So I have to follow the road where we go mass to moles to particles. Let's say I wanted to go from atoms to liters. How many liters are in 6 atoms of nitrogen? I can't go around that way. There's no road there. So you follow the road from atoms to moles to liters. So that's always what you're going to do, is go to moles first when you are doing conversions that take more than one step. And you'll know it takes more than one step because the word mole is not in the problem. So here's how these look. I want to know how many atoms are in a 44.3 gram piece of iron. So process stays exactly the same. Write down what you're given. 44.3 grams of iron. Cancel that unit every single time. What's different here is I can't put atoms on top because I don't know how many atoms are in a gram or how many grams are, well, there's no grams in an atom. Atoms are too small. So this is what I'm saying is where you have to go to moles first. So we're going to go grams to moles. 1 still always goes with mole. Gram, if you look back at your conversion factors, grams comes off the periodic table. So for iron, it's 55.85. And now we're at moles of iron. I got to get to atoms. I circled the word atom. So I have to keep this conversion going until I get to the word I circled. So I'm going to cancel. I'm just going to extend my T. I'm going to cancel mole on the bottom. And then I'm going to go to atoms on top. 1 always goes with mole. And then with atoms, if you look at your conversion factor, it's 6.02 times 10 to the 23rd. So, get my calculator going here. When you are doing this, again, you're going to multiply everything on the top together. So 44.3 times 6.02 times 10 to the 23rd. And you're going to get 2.66686. Ooh, I'm going to run out of room. Times 10 to the 25th. Multiply everything on the bottom together. And then divide those two numbers. And, hold on just a second here, sorry. Okay, my calculator wants to not work very nicely right now. Should get, oh, right. Okay, so you should get like 4.77 times 10 to the probably 23rd. Like I said, my calculator's not working great, sorry. Atoms of iron. This was 3 sig figs, so I took my answer to 3 sig figs. Oops. Let me just double check. Yeah, close enough. So I'll just do one more. I want to know, I have this many molecules of iodine. I want to know what the volume is. Remember, iodine, again, is one of our diatomics. So when I'm writing it, 5.24 times 10 to the 22nd molecules. You can abbreviate, but I would go at least like to the C, just because you don't want to get it confused with mole. Iodine, cancel, and we go to mole. You always have to go to mole first. 1 always goes with mole. Wow, I don't know what I was thinking. Sorry about that. 6.02 times 10 to the 23rd is going to go with molecule. I got to get to volume, so I'm going to do one more step where I cancel mole. And I get to liters. 1 goes with mole, 22.4 goes with liters. So, multiply across the top, divide by what's on the bottom, you'll get your answer. So I hope that helped. Let me know if you need additional help. But yeah, that's all the notes from last week.